Practice set 7. Use the sine formula to determine the length of side x in each triangle. Use examples 25 and 26 for reference. Write your answers to the nearest tenth. We're going to use this acute angle that's given as our reference angle to label the sides of the triangle. Always starting with the side opposite the right angle, the longest side. We have that the hypotenuse is 32. Given the 15-degree angle is our reference angle, this side designated by the unknown length is our opposite, and the third side with no information is the adjacent. Using the sine ratio of an acute angle in a right triangle, by definition, equal to the opposite side length over the hypotenuse, we will find the length of that unknown side. Replacing the unknowns with values pertinent to this given triangle, sine angle A, we'll replace that A with 15 degrees. Opposite is what we're trying to determine. We'll use the x that was given, and the hypotenuse has a length of 32. You can think of this equation as something that looks like what you would see in an algebra course. We're trying to solve for x. It's being divided. To counter or undo a division, we will do the opposite operation of multiplying. And to maintain the equality, what we do to one side, we need to do to the other side. Simplifying on the left, let's find the sine of 15 degrees using your calculator. On the right-hand side, the 32 has a denominator of 1. That's going to cancel out the 32 in the denominator. 32 divided by 32 is 1. 1 times x will give us a value of x. Simplifying further on the left-hand side, when we multiply and round to the nearest tenth, we have our answer that we're looking for. The length of the opposite side has a length of 8.3. Problem number 2, following the same procedure, we're going to identify the given angle measurement in this triangle as our reference angle. It will be our home base for labeling the sides of the right triangle. Always starting with the longest side or the side opposite the hypotenuse first. Next, we will label the opposite side from our reference angle. That's the side we're trying to determine the length, and the third side is the adjacent side. Using the sine ratio and plugging in the values that we know that our angle has a measure of 60 degrees that we're using as the reference. The opposite side is the unknown, and the hypotenuse has a length of 6.4. This also looks like a classic algebra problem. To undo the division and get the variable by itself, we will multiply to cancel out the division, maintaining equality. That means both sides need to be multiplied by 6.4. First step to simplify on the left, find the value of sine of 60 degrees using your calculator. 0.866 is that value. Simplifying on the right, the 6.4 in the numerator divided by 6.4 in the denominator leaves us with a 1. X times 1 is x divided by 1 gives us x. And the last step, do the last multiplication implied here to simplify, and only now will we round, and rounding to the nearest tenth, we find that the length of this unknown leg opposite of our reference angle is 5.5.